Hi, and this is lesson 6.2, and we are solving inequalities using multiplication and division. What you're going to notice real quick today is that this section is really almost exactly what we did in the last section, except we're going to be solving inequalities that require multiplication and division as the inverse operation versus addition or subtraction. Let me just quickly review what we did in that last section. I'm going to pick something basic here, like x minus 5 is greater than or equal to negative 2. I want to solve this inequality. So to solve this, we have to get x isolated by itself, and we don't want minus 5 here, and so we're going to add 5 to each side. So remember, that's called an inverse operation. We were adding 5 to each side, and that's what last section was about. It was solving inequalities using, remember, it was addition or subtraction. We're adding here to do this. And you would get x greater than or equal 3. And then you would take graph paper, and you would go and you'd shade color in 3 because we can equal 3. And then you would shade to the right all values that were greater than 3. That would be a review of what we did last section. Now today we're doing the same thing. We are still solving inequalities, but this time we're going to solve inequalities that could require us to multiply or divide. Okay? And I think the easiest thing to do on that would be to just do a few together. And if you go to page 366 and we go to question number 3, for example, we have 2p is greater than or equal to 14. And we want to solve this inequality and graph it. Well, remember, to get p by itself, I have to get rid of this times 2. And the inverse operation of multiplying by 2 is to divide by 2. So remember, if I divide by 2 on the left, I got to go to the right and do the same, or my scale becomes unbalanced, and that would mess up my equation. I would not get an equivalent inequality, and I'll divide by 2, and p greater than equals 7, and then I should graph this. So here is 7. I'm shading it in because they're coloring in the dot because it's equal, and I want the values that are greater than that. And I'll put an arrow at the end here. I want the values greater than or equal to 7. Now there is one important point. I think that's a pretty simple concept what we did there. There is one very important point that we got to be careful of regarding multiplying and dividing inequalities, and maybe I should just write it on here. And I'll just I think maybe I should just do this in a different color. This is very important, okay? When solving inequalities, I'm just going to write this out. When solving inequalities, be nice if I could spell right. When solving inequalities, okay, if you multiply or divide by a negative amount, you must flip the inequality symbol. So if you multiply or divide each side of your inequality by a negative amount, if you do that, okay, you must reverse the inequality symbol. Inequality symbol, okay? That is a huge deal. In fact, that's probably the major thing in this video that I have to emphasize. If you get this down, the rest of this is going to be a piece of cake. An example of what I'm showing or talking about here could be, well, look at number 4. Now, number 4 is x divided by negative 3 is less than negative 10. Okay, so I want to solve for x. So I got to get rid of negative 3. Well, the way to get rid of negative 3 is to multiply each side by negative 3. Now, Since you're multiplying each side of an inequality by the negative amount, you must flip that inequality. So what I'm showing you, what I wrote here, I'm showing you right here. Okay, since I multiplied each side of my inequality by a negative amount, I must flip the inequality symbol. So going back to my work, these cancel, I get x, and negative 10 times negative 3 is 30. I must use x values greater than 30 to make this a true statement. So now I'm going to go and graph that. I'll change my scale here. I'll go 10, 20, 30, 40, 50, and so on. I'm changing my scale. And so I want values that are 30. I'll put open circle at 30. It didn't equal 30. It just started at 30. And I want values greater than 30. Actually, I can check this. It'd be probably smart to check, because some of you might be like, well, why would I reverse the symbol? Let's think. Let's pick a value that's greater than 30, like I'll pick 40. And you can take your calculator. If you plug in a 40 here and you do 40 divided by negative 3 to check, 40 divided by negative 3 is like negative 13 point something. Is negative 13 point something less than negative 10? Think about a number line. Is negative 13 point something less than negative 10? And the answer would be yes, it is, because negative 13 is farther left on my number line than negative 10, so yes, it is less. So I actually got to plug a number greater than 30 for x to make this work out to something less than negative 10. Whenever you multiply or divide each side of your equation by a negative amount, you have to flip the inequality symbol. That's probably the main thing of today's video. I'll do one more here, just to do one more, and I think that might be enough examples. This video actually shouldn't take us too long. I'm at 7 minutes right now. Okay? What about in question 15? It says negative 8.4f is greater than 2.1. Well, I want to solve for f. I got to get rid of times negative 8.4. So, of course, I should divide by negative 8.4. Now we got to be real careful. I got to apply this. Since I'm dividing each side by a negative, I must reverse this inequality symbol for my response. So f would end up being less than, it would be less than, if I put this in my calculator, that's a quarter, a negative quarter. Okay, so f has to be less than negative quarter. I got to plug in values less than negative quarter to make this greater than 2.1. Let's try that. Let's pick an amount less than negative quarter, like negative 1. If I plug in negative 1, let's see if this works. Negative 8.4 times negative 1 is positive 8.4, and positive 8.4 is definitely greater than 2.1. That works, okay? So I just checked my answer on that also. All right, so again, everything we're doing here is exactly, I think it's very basic. It's just basic one-step equation solving, except when we solve inequalities, if we multiply or divide by a negative amount, you must reverse the inequality. Let me just quickly point out one common mistake that I've seen people make. Now remember, I'm going to highlight this again. Let me just circle it in green. Okay? Be aware. What I told you here only applies for multiplying and dividing. If you multiply or divide each side by a negative amount, you must flip the inequality. Okay? Here would be a common mistake. I'll put it in red, common error. And I've seen people do this, which is why I'm talking about it right now. Okay? I've seen people that we've talked about this concept, and then I go back and give them an equation like this. And they subtract 5 from each side correctly, and then the next thing you know is they're writing this on paper. They're going and they're canceling, and they're saying x, 3, which is correct. Let me write that better. X and 3, but then for some reason they are reversing the inequality symbol incorrectly. This is incorrect. I'm doing it in red. Did we multiply or divide each side of this by a negative amount? And the answer is obviously no. No, I didn't divide by a negative. I just subtracted, okay? What we did up here only applies if you're multiplying or dividing each side by a negative. So to do this correctly, to get this correct, I do not want to reverse the inequality. I would just want to keep it moving in the same direction, okay? I think that is adequate for what we needed to know from this video. We're going to solve inequalities and still graph them. Again, the big deal today, the big deal would be right here. If you multiply or divide each side of a inequality by a negative amount, you must reverse that inequality symbol.